It's the last video on intervals of convergence, and we've been ignoring this check your endpoints thing. And so today we finally do it. And before we get going, I found this quote. I think it was from Leibniz, but I'm not sure. But Leibniz understood the importance of checking your endpoints. And so I think he was quoted as saying, check yourself before you wreck yourself. Thank you for those words of wisdom, Leibniz. The example we're going to use this alternating series. There's the alternator right there. And I can tell that I'm doing an interval of convergence because I have the x floating around within the series. And I'm not going to do the work on this one, but if I did, via the ratio test, I would come up with all of this information, and I see this nice, tidy interval of convergence, and x equals 1 is the center. I could tell that just from looking at that. But now here's the new item for our brain. I see my interval of convergence is informally called 0 to 2, and I'm using some soft brackets. But the final answer could be that, but I could have a hard bracket on the left or the right or both. I don't know. So that's why I need to check the endpoints of x equals 0 and x equals 2 so I know which one of these to choose. And testing an endpoint is going to be actually nothing new to your brain. If I was going to test an x equals 0, because I've identified that x equals 0 is an endpoint in my interval, I simply take the x equals 0 and replace that x with a 0. So I'm just rewriting the series, and you see that the 0 has replaced the x. What I've done now is I've transformed this series back into one of those series we used to work on where there wasn't any x. So I just need to take this clunky thing and determine convergence or divergence using one of those myriad of tests available to us. Now sometimes these can get a little bit kind of tricky, you do a little bit of arithmetic gymnastics. But if I replace x equals 0 there, that means that's just a -1 to the n power. And what I have is an alternator and another alternator working within the same series. But if I do a little algebra, I can say when I multiply, I add exponents. So this numerator just becomes -1 to the 2n plus 1. Now from here, you might be able to just reason out that by plugging in any n value, my exponent is going to be odd. You just take my word for it, it will, or just start plugging in different n's, but you'll always end up with an odd exponent, which means you'll always end up with a -1 in the numerator, and the denominator is just getting larger and larger, n equals 1, 2, 3, 4, 5. We have a divergent harmonic series. The fact that it's negative doesn't matter. It's still a divergent harmonic series. If you don't like those gymnastics, then just start plugging in a 1, a 2, a 3, and you'll get something like that or like that, and you'll see for your very eyes that it's a harmonic series, and we know the harmonic series is divergent. The bottom line, though, is this. When we plugged in an x equals 0, we get a conclusion of divergence, which tells us that we will need to use the soft bracket on the 0. Oop, you can't see that. We'll need to use the soft bracket on the 0 because 0 does not allow the series to be convergent, so 0 should not be included in the interval of convergence, so we exclude the x equals 0. So similar to what we just did on x equals 0, for x equals 2, where I used to see an x in my series, I put a 2. And what I've done is I've made for myself a problem where I have to decide convergent or divergent. So I would try whatever test works for me. In this case, I recognize it to be an alternating series. If it's an alternating series, I can go through the alternating series test, and without bothering to do all that work, I end up with a conclusion of convergence. So that means x equals 2 made it convergent. So if I was doing an interval of a convergence, I would want to include 2 in my interval. So that means my very final answer is the interval of convergence is x equals 0, don't include 0, to x equals 2, do include x equals 2. So as you're checking for your endpoints, the AP grader should be able to see some documentation like this so they understand how you came to your final conclusion. That's the last video on intervals of convergence.